In lesson 6.7, we are going to use everything that we've talked about with our trig functions and inverse trig functions to solve some application problems. So we'll start out with a lot of review from stuff you would have done in geometry. The first thing is to solve a triangle. Solving a triangle means that we are going to find all angles and sides. Now, we can do this with a lot of different tools. We can use Pythagorean theorem. We can use the fact that all the angles add up to 180 degrees. We can use SOHCAHTOA, and we can use inverse trig functions. So here we have this triangle. We know that we have a 90-degree angle and a 20-degree angle, so angle B should be pretty easy to find. We just add up our angles and subtract from 180, so angle B is going to be 70 degrees. Next, we need to find sides A and C. It doesn't matter which ones we find next. I'm going to find angle A. So I can't use the Pythagorean theorem because I don't have enough sides, but I do know that this is a 20-degree angle, and this is the opposite side, and I know the adjacent side. So tangent uses opposite and adjacent, so I can say the tangent of 20 is A over 15, and then I'm going to multiply both sides by 15. We're in degrees now, so make sure your calculator is in degree mode, and 15 times the tangent of 20 is right around 5.5. So we know that side A is 5.5. Now to find side C, we can use the Pythagorean theorem. The one slight downside of doing that is this is a rounded value, so you're going to have a little bit of rounding error. If you want to avoid that, you could use like cosine instead. But for now, I think Pythagorean theorem is okay. We can do 5.5 squared plus 15 squared is c squared. And when you solve that, I think you get right around 16. So that is solving a triangle. Then we are going to move into a little bit more complicated problems. This one's not that bad. So we have a ladder that is 16 feet long, and it leads against the side of a house. So here's the house. We're assuming it makes a right angle. And then there's a 16-foot ladder. The angle of elevation, so angle of elevation is from the horizontal up. That's 80 degrees. Find the height from the top of the ladder to the ground. So we want to find that. So this is just a basic SOHCAHTOA problem. We have opposite and hypotenuse. So we're going to say the sine of 80 is x over 16. Just multiply both sides by 16 to get those to cancel. Again, make sure you're in degree mode when you put this into your calculator, and you get 15.8 feet. Okay, let's make things a little bit more interesting here. So we are 60 feet from the base of a church. Okay, so here's the church, and we're 65 feet away. The angle of elevation to the bottom of the steeple, so here's the bottom of the steeple, is 35 degrees. And then the angle of elevation to the top of the steeple, there's the top. Okay, and then this is 43, which I'm going to have trouble writing in there. So let's put it there, 43 degrees. Let me label that a little bit better. That's this bigger angle. And we want to find the height of the steeple. This, I'm going to call that x. Okay. Well, let's call this part y. That's going to be the height of the church. So I think we saw a similar problem to this maybe last, or the early part of this chapter. So first, let's look at this slightly smaller triangle. Okay, with this 35-degree angle, we know that the tangent of a 35-degree angle is going to be y over 65. So we can solve that. We're going to multiply both sides by 65. Again, we're in degree mode, so we know that the church is, 45.5. Now let's take a look at the bigger triangle, this one. Okay. So again, we're dealing with the opposite side and the adjacent side, so we're going to use tangent again. So the tangent of this time, the angle is 43 degrees. The opposite side is x plus y, so x plus 45.5. over the adjacent, which is 65. So we'll multiply both sides by 65. So 65 tangent of 43. And then we'll put this into our calculator. Well, first we'll subtract 45.5 from both sides. Now, obviously, those are not like terms. So now what you're going to do is go to your calculator and type in 65 tangent 45. Make sure you close the parentheses, and then subtract 45.5, and we get 15.1 feet. And that's how tall the steeple is. For example number 4, we have from the time a small airplane is 100 feet high and 1,600 ground feet from its landing runway, the plane descends in a straight line to the runway. We want to determine the angle of descent. Okay, so we have this airplane. That didn't work out very well. Let's try again. It's 100 feet high. And the ground distance, that's the distance along the ground, it's 1,600 feet. That is not drawn to scale, but whatever. Okay, so it is going to, this is the runway starts here. Okay, so it's going to start descending so that it can hit the runway, and let's just pretend that triangle's a little bit longer. Okay, so that's the situation we have going on here. Now, we want to determine the angle of descent. Now, from your airplane, the angle of descent, it's the same as the angle of depression. So it's this angle. Okay, now notice that angle is not in the triangle, because your triangle's down here. But using alternate interior angles, this is the angle we're trying to find. These two are going to be congruent, so this is angle theta, and that's going to determine our angle of descent. So this looks like a tangent problem. Okay, the tangent of angle theta is 100 over 1,600. And we need to solve for theta. So the way we're going to do that is we're going to do the inverse, because that undoes the tangent function. So inverse tangent and tangent will cancel each other out. And in your calculator, you're going to do the inverse tangent of 100 over 1,600. And you will get 3.6 degrees.